In the last part of 2.3, we're going to put everything together now. We're going to talk about our behavior at the far left and far right. We're going to find the zeros algebraically. We're also going to find the y-intercept. Remember, the zeros are the x-intercept. We're going to determine if there's any symmetry. We've done that in previous videos as well. We'll go back and revisit that. We'll talk about the number of turning points, but we're not really going to get into too much about what we do with those. And then we'll find one or two more points on the graph just to give ourselves the ability to make a sketch, and then we'll go ahead and plug it in the calculator and just see what it looks like. All right. So the first example we have here, right? First thing they ask us to do is to determine the far left and far right behavior. Remember, we have to find the highest degree. In this case, we have degree 4. My leading coefficient is 2. And so that's positive. If my leading coefficient is positive and I have an even powered polynomial, then the far left is up and so is the far right. Okay, so the end behavior is that it points up on both sides. Okay. Second part says, you know what, let's go ahead and find the zeros. So remember from the previous examples, we just set this equal to 0 and solve for x. You might notice that these two terms here have a 2x squared in common. So I will go ahead and factor that out. That'll leave me with x squared minus 4. X squared minus 4 is the difference of two perfect squares. In the previous video, I showed you how to go ahead and handle that. So you might recall, or if you need, go back and watch that video again, that this becomes x minus 2, x plus 2. Again, we call those conjugates, right? That's a conjugate pair. So they're the same terms, but different sign between them. So this is our completely factored form. We would then take each one of the terms, set them equal to 0, and solve. So we have 2x squared equals 0, divide by 2. We have this, take the square root of both sides, and we get x equals 0. Okay. Then we have x minus 2 could be 0. Add 2 to both sides, and you get x is 2. And then we have x plus 2 could be 0, or x is negative 2. So these are our roots. And if we wanted the actual intercepts, right, we just put them as an ordered pair, paired with y equals 0. Okay. Again, the first point, because of that the x squared, that makes it a multiplicity 2. The other 2 points are multiplicity 1. And so remember that multiplicity 1 means we pass through, right, or we cross the x-axis. And multiplicity 2 means we touch and turn. Okay. Part 3 says, while you're at it, can you please tell me what is the y-intercept? Well, the y-intercept occurs when x is equal to 0. So I'm going to say this is y equals 2 times 0 to the 4th minus 8 times 0 squared. 0 to any power is still 0. So both of these just become 0 and we get y equals 0. Or if we want to write it as an ordered pair, it's the point 0, 0, which, don't forget, is called the origin. Now to determine if we have any symmetry, we are going to look at the function and determine if it is equal to the function when negative x is plugged in. Remember, this is an even function, which means that we have symmetry about the y-axis. And then if that's not the case, then we would look to see if f of negative x is equal to negative f of x. If that's the case, this is odd, and this has symmetry about the origin. Okay, so let's go ahead and test this. Let's see which one we might have. So first we need to just plug in negative x into the function. All right, so plugging negative x in, all right, we have f of negative x is equal to 2 times minus x to the fourth minus 8 times negative x squared. Remember, if we have an even power and it's a negative value, it's going to become positive after you've raised it to that power. So 2x to the fourth minus 8x squared. This is indeed equal to the original, and therefore this is an even function, and it has symmetry about the y-axis. All right. Number 5, number of turning points. It's n minus 1, and n is our degree, so the number of turning points will be 3. Now, when you get into calculus, you'll do a little bit more with this. These are going to happen at extremes, where we're talking about maximums and minimums, and you'll be able to figure that out using a derivative. But for now, we're just going to say how many turning points are there. All right. So we might want to get a little sketch going now with what we have. So far we have that we touch at x equals 0. We know that the y-intercept's also 0, 0. We touch at x equals 2 and x equals negative 2. We know that it's up on both sides, right? And we know that we cross at x equal 2 and x equal negative 2, which means this thing has to go below the axis on both of these, and then it's got to touch and bounce back at this point. So we're going to get that basic x to the fourth shape. What we might want to do is we might want to plug values in to get the depth at which this goes down. But at this point, right, we understand what the sketch looks like. I'm going to go ahead and just plug this into Desmos and take a look. All right, here's our function. Again, you can see we touch at 0, we touch at negative 2, and we touch at 2. We cross at negative 2 and 2. We touch and turn at 0, 0. And we have symmetry about the y-axis because it's an even function. Here we are with another example. Again, we have x to the fourth as our highest power. So our degree is 4. And our leading coefficient in this case is 1. That's greater than 0, or we can say it's positive. So we know that we have a degree 4 and it's positive. We know that then at the far left and far right that this thing is going to be going up, just like the previous example. Next, we need to figure out where does it touch or cross the x-axis. Those are at the zeros, so we need to factor this as best we can. There is a factor of x squared that can come out of everything, leaving me with this. I can continue to factor this, right, at this quadratic here. We need two numbers that multiply to 4 and add to 4. So if I'm trying to multiply to 4 and add to 4, that's x plus 2 times x plus 2. And in fact, we can write that this way. And we do it this way because that tells us that each one of those have a multiplicity 2, which means that when we touch the axis, we're going to turn around. Okay? So let's see. Each one of these tells me that x equals 0 from this one. This one tells me that x equals negative 2. All right, so these are my x-intercepts. I can find my y-intercepts by setting x equal to 0. And again, this is the nice thing about polynomials. Notice that each one of these terms has an x. So if I plug in 0, they all go to 0. And so I get y equals 0 and the origin again. Okay? All right, next we're asked to tell if there's any symmetry here. So let's see. I need to plug in the functions. So I have f of negative x. I need to try. That's going to give me minus x to the fourth plus 4 times minus x cubed plus 4 times minus x squared. Negative powers is going to become positive, so this is x to the 4th. Odd powers turn negative, so I have this and this. That is not equal to f of x, so it is not even. If it's not even, it could be odd, so we try that. So now I need to find what is negative f of x. So that's just taking the negative of the entire original function, which would look not like that, but more if we take a negative of everything, which is what I was supposed to do. There we go. Okay, so this is what we would end up with. So f of negative x does not equal negative f of x. So this is not odd either. So we would say this is neither, or there's no symmetry. Okay, and you might go back and look at one of the other examples we had earlier. We had two terms that were even, one was odd, and it made it not symmetric about the y-axis, and it certainly wasn't symmetric about the origin. The other things that we can do is we can look at the number of turning points, which in this case, right, it's n minus 1. N is 4, so the number of turning points is 3. All right. Again, you'll do more with that when you get to calculus. And then last thing is we really just want to come up with some kind of idea of the graph. So we know that it's to the 4th, so it's got this kind of W shape. It touches at 0, and it touches at -2. It has behavior that's up on both sides. My guess is it's going to do something like this. So again, let's just hop over to Desmos just to prove what this thing looks like and show that we've come up with a decent idea. So in the unfactored form, right, x to the 4th plus 4x cubed plus 4x squared gives me that equation and that function. That looks pretty good compared to what we just did. So we have -2, we touch and turn, 0, we touch and turn, and there happens to be this point here, which again, you'll look at in calculus, which is a point of inflection. All right, we've got one more example. All right, so for this example, yet again, we need to find the leading coefficient. Don't let it fool you, right? Because this is first, it's not the highest power. Instead, x to the 5th is the highest power. So my degree is 5, and my leading coefficient is 1, which is greater than 0 or positive. So this time we have an odd power with a positive leading coefficient. We should expect this kind of behavior, which means that the far left is down and the far right is up. Okay. Then we need to figure out where is across the x-axis. So I'm going to write this guy in descending order and factor and solve for x. Each of these has at least an x in common, so factor that out. That leaves me with x to the 4th minus 4x squared plus 4. I can factor this. I'm still looking for two numbers that multiply to 4 and add to -4. Those would be -2 and -2 again. Notice I have x squared and x squared. That's required in order for me to get x to the 4th, right, for that term right there. Okay, so that's the correct factored form. I would also write it this way, just so we understand that this one has multiplicity 2. Okay. All right, setting each one of those equal to 0, we get x equals 0 is one of the roots. The other root, we have x squared minus 2 squared is 0. Take the square root of both sides, and I get x squared minus 2 equals 0. Then I would move the 2 to the other side and take the square root again. In this case, I have to be careful that I get plus and minus root 2 on the right-hand side. Okay, so we get the roots x equals plus root 2 and x equal minus root 2, each of which have multiplicity 2. Okay, all right, so we've got all of our roots. We need to find where does this thing cross the y-axis. So that would occur when x is 0. So we would plug in 0 into the function, which once again is really nice because all of this goes to 0. So we're still going through the origin yet again. All right, so we know where we touch the x-axis. We know where we touch the y-axis. We need to see if there's any symmetry. So to do that, we're going to look at f of negative x. All right, so we need to plug negative x into the original function. So that's going to be negative x to the 5th minus 4 times negative x cubed plus 4 times negative x. That's going to give me minus x to the 5th plus 4x cubed minus 4x. This is not equal to the original. So the next thing we want to do is do minus f of x and see if that gives us the answer that we're searching for. That's going to give us minus x to the 5th plus x to the 3rd minus 4x. Look at that. Those two are equal. That means that this is odd and it has symmetry about the origin. Okay. Then we want to talk about the turning points. N was equal to 5. So the number of turning points, which is 1 less than that, is 4. All right. So let's just go ahead and throw this in to Desmos. We want the function x to the 5th minus 4x cubed plus 4x. There we are. All right, so x to the 5th minus 4x cubed plus 4x looks good. We touch and turn at negative root 2. Right, there's a point of inflection that we haven't figured out how to determine yet. We cross at 0, 0. Right, that had a multiplicity of 1. And yet again, we touch and turn at root 2, which had multiplicity 2 as well. Again, we have that overall S pattern, but we have a couple more wiggles, as we would say. That's because we're getting into x to the 5th. If we had something like x to the 7th, you would expect another set of wiggles in there, if you will. Anyhow, that's the rest of 2, 3.